Very good morning to all offline and online delegates. This is Adinarayana from India. I work for an institute called Indian Institute of Technology. You can call me in short Adi. You don't need to call me completely Adinarayana. I have been the member of this agriculture working group for quite some time. This agriculture group, I'll just share my video. I hope am I visible, please? Yes, I think so.
Yes.
Yeah. So
yes.
Thank you. And this agriculture working group, friends, started with the seminal initiation or contribution from Professor Ninomiya and his group from Japan. And really delighted to see the involvement of the current status of this group. These sessions also trigger quite a few what to call collaborations and R&D projects, one of which recently completed is, in short, we call it CRADA, Climate Resilient Agriculture for Disaster Risk Reduction from AsiaNet from TN European Commission. Of course, this is by multiple countries. So that's the advantage of having this network, and then network of the countries and the agriculture working group, people from Asia Pacific region. It has been taking the audience with the contemporary agriculture, and I'm sure today also we will have presentations followed by discussions. It's my great privilege and pleasure to chair this session, friends. I see 3 presentations. Let's give each one, if everybody agrees, then 20 minutes, and let's give 15 minutes for presentation and 5 minutes for the discussion. And in the end also, we can have discussions. I have with me online Professor Demitu Piyaratne. Professor Piyaratne, please apologize. I apologize for my pronunciation. And his topic is really interesting in the local system, how the agroinformatics activities are taking place in Sri Lanka. Professor Piyaratne, if you're ready, please go ahead. Yes. As I said, 15 minutes plus 5 minutes discussion. Thank you very much.
Yes, thank you, Professor Adi. Let me share my screen. Right, I think you can visible, right, my screen?
Yes.
Okay, thank you. And very good morning to all. And I am Piyaratne. I am working as a professor in agroinformatics, Faculty of Agriculture, University of Kuhuna. Actually, for this speech, one of my colleagues invited me to have this. He's Professor Subhash, the Dean of Technology Faculty in the same university. So I must thankful to him. And let me start this. What actually I want to start this by recapping our ancient history, showing what our great kings did for the country. I think this is King Parakram Bahu, who ruled the country 1153 to 1186. What I highlight this is actually one of his most famous utterances. Just read it, not even a drop of water that comes from the rain must flow into the ocean without being made useful to man. Right, you can understand that. I think this explains his dedication given to the agriculture, and at the same time, the country was called as Granary of the East. right? Why? Because that in that time, the country was self-sufficient in agricultural products, especially rice and all other grains. This is actually timely important because nowadays you may heard that the country is facing very huge water crisis. So I just want to highlight this. I think it is estimated that we are going to lose the complete yield from around 100,000 hectare paddy fields. That is a huge crisis. And that also I want to highlight that this king is said to have restored or constructed over 165 large tanks. In addition, he renovated over 2,000 minor tanks and closely 4,000 canals and 163 dams. I think I thought to start from this because this is very timely important topic. So especially in this agriculture field in the country. Right. Just this is my outline. I want to discuss about some statistics related to agriculture and highlight some points where we need or why we need technology. And then I want to highlight some strategical points developed by agriculture strategy. And then I will discuss some activities currently going on in the country. Right. This is about population actually in Sri Lanka, 22 million we have, and with the total land area is 65,000 square kilometers. From that, only 33, around nearly 40% employed in the agriculture sector. And around 42% land area devoted to agriculture. I think this is quite reasonable amounts, but the problem is that only share of agriculture in GDP is 8%. That is the problem. Now we have a challenge. We need to increase the GDP share with high productivity and also with quality products. That is the challenge. So I need to discuss where we need technology or why we need technology. Actually, I will highlight some points, especially water scarcity, because you know that we need water for electricity, household consumption, industry, and also agriculture. Right? In these days, this is a huge crisis, water scarcity, right? So even everywhere, you know that declining arable lands, not even Sri Lanka or in other countries, right? Maybe some different reasons for that, urbanization, industry, or some erosion, degradation like that. And also another one, adverse environmental conditions. Maybe floods, maybe drought, landslides, whatever. Drought is especially hitting these days in Sri Lanka, right? That is what I want to highlight, that in about labor, high cost labor. Because you know that our agriculture, most operations are labor incentive. So now maybe we have labor, but very high cost or maybe unavailable labor, right? Then fertilizer issue, another one, maybe the cost or maybe improper usage, maybe due to that environmental hazards. That is another one. We need to apply technology to reduce that. And also improve quality and productivity is another question. We need to use technology to improve the productivity with the quality. And then next one, year-round supply. Because you know that in the season, we have a lot of production, maybe low price and wastage due to that low price. And what will happen in off-season? Low productivity, then high price. That is, we need to synchronize this and ensure that year-round quality supply. And also, I want to tell something about COVID-19 pandemic. Because you know that we cannot forget that around early 2020, it has had a massive impact on Sri Lanka's national economy, not only for agriculture, but almost all sectors in the economy had affected. But in a positive thing that, in other words, that was a boost for the digital transformation in all sectors, especially in agriculture and all other sectors. I just mentioned that. Right. Next, let me discuss about our strategy. This is Sri Lanka e-agriculture strategy. Actually, this was developed in 2016 under the framework proposed by Food and Agriculture Organization and ITU, International Telecommunication Union. This identified the challenges and potential areas where we can apply technology to improve the quality and productivity. However, depending on the level of impact on agriculture supply or value chains, we can use the technology in 3 ways. I will come to that, maybe high impact technology, or maybe medium impact, or maybe low impact. We need to understand where we apply. In other way, we have a complete system, complete ecosystem, right? From farmer to consumer. This is a network. Maybe we can discuss about the value chain or supply chain like that. We need to address all entities in the system. Otherwise, we will fail, right? So then what they discuss in the strategy, they have identified priority objectives for the agriculture sector. Just I highlight some points. You know that self-sufficiency in food crops, availability of safe food, food security, and increase the productivity. And this red one is very important. Establish proper coordination among all agricultural stakeholders in the local food production process, and connect all schools, civil organizations, and general public to the program. I think not only that, I suggest that we need to include all universities into this. And also, next one, establish proper marketing mechanism. That is what really we need in this moment. I think we need to we should collaborate all data collectors in all sectors and manage to develop comprehensive database for the entire system. That is what we need. And also, we need to develop a comprehensive marketing mechanism to address to the supply of value chain of all food items. These are the challenges in category. They identified policies, guidelines, and regulatory frameworks, resource constraints in value chain and marketing, data availability, knowledge, lack of services. All these categorized, and they identified there are 97 challenges under these 8 categories. I'm not going to discuss all these, but want to highlight some potential applications of ICTs to improve existing agriculture system and the information collection efficiencies and services, all other things. Here you can see they have listed out these services, e-services especially. I think you can understand that low impact technologies are coming to these systems. Actually, however, I think these potential areas for application should be revised, as these are quite outdated because this strategy was developed in 2016. I think a new strategy should be developed to address the current issues with applying recent technologies. We can discuss what are the technologies. And I think now, according to the Department of Agriculture, Sri Lanka, it is on discussion level with the FAO. Hopefully, we will have a new strategy soon. So then we can go with that And now I come to the technology in agriculture or value supply chain where we can apply. First one is high impact technologies like Internet of Things, automation and robotics, AI, big data like that. Already we have applied some technologies in the country in the agriculture sector. And then medium impact technologies like blockchain, global navigation satellite systems, virtual reality or augmented reality, like technologies. I think these technologies highly impacted in the system in long run. Not like that high impact technologies. And low impact technologies like broadband or fiber networks, information and communication.
Professor Pieratne, sorry to interrupt. I'm not able to hear Professor Pieratne.
It's seem to be lost connection.
Yeah, I think so. Yeah. Professor Pieratne? Can you put your audio on?
Yes, I think that is disconnected, right?
Yeah, we lost you for
Yeah.
at least about a couple of minutes.
Can you remind me that where I disconnected?
Yeah, please share the screen. You're talking about those technologies. Yeah, I'm able to see the slides. Go to the 5th or 6th one. No, the previous one. Previous. You're just introducing those technologies.
Great. Here, I think, right?
Yes, yes, yes. May I request you, Dr. Pieratne, to speed up your presentation?
Okay, right. Actually, these are the technologies where we can apply in the system. And now I want to discuss about the services given by the government institutions. I think low impact technologies are well established in the country through the robust telecommunications infrastructure with the private sector involvements, because we have FTTH, satellite TV, and a broader coverage of 5G or 4G, 3G networks. And Department of Agriculture actually has taken several measures to implement many innovative solutions like mobile apps, website, information systems, and SMS service like that. And also we have certification service, seed certification service, and good agricultural practices certification. And also they have radio and TV services and also social media. They are using very effectively these tools with the farmers. And this is the website of the Department of Agriculture. You can see a lot of institutions under that department. And I want to highlight that National Agriculture Information Communication Center, NAICC, because they are giving a lot of services. Let's go to that website. Yeah, this is the NAICC website. 1920 Agriculture Advisory Service is very important tool. That is advisory service. You know, if I explain this more, you know that this service provided all farmers in the country, they are receiving calls, around 400 calls per day. That is around 10,000 per month and 100,000 per year. That is very effective service in the farmers. And then Also, they have started ESM service, that is called SMS alert service. That is already farmers can register, and already they have included 10 special crops like paddy, maize, chili, big onion, banana, papaya, potato, and tomato, brinjal, and loofah. They have planned, actually they are using now 25,000 alerts per month, like availability, like pest and disease outbreaks, market information, everything. They are updating with the farmers. That is how they are working there. And then that is another screenshot of that website: agriculture video photography, farm broadcasting services, central agriculture library, technology park, like that. Those are all services they are giving through the farmers, the website to farmers. Then I want to discuss about what the ministry has done. They are started several projects to uplift the agriculture sector. This is one of that project, agriculture sector modernization project. This aims to support smallholder farmers to produce competitive high-value agriculture products and improve their ability to respond to the market needs and access domestic and international markets, and become efficient and sustainable market participants. That is actually very, very active project, and a lot of benefits to the farmers already. I think that is the already close to end that project, but very successful, I think. This is another project, climate smart irrigated agriculture project, also implemented by the Department, Ministry of Agriculture. This is actually they plan to renovate irrigation systems in 11 districts in dry zone. Maybe 1,700 minor or medium irrigation schemes will be renovated to benefit over 60,000 farm families. That is a good project. Also, under this, they have started climate smart agriculture school. We call it Farmer Field School at Tirappan area, that is in Anuradhapura district in North Central Province in Sri Lanka. They are promoting climate smart agriculture practices from that school, that is actual training center. This is first time in Sri Lanka. In addition, there are more projects such as Smallholder Agribusiness Partnership Program and Smallholder Agribusiness Resilience Project are also active from the Ministry of Agriculture. Then I want to highlight some from the ICTA. This is the Information and Communication Technology Agency in Sri Lanka. They are also at the forefront of driving digital transformation to make Sri Lanka a digital inclusive nation. I think they have already conducted a series of workshops to discuss innovations, what we can apply to uplift the agriculture sector. That is the AgTech Showcase, that is their initiative. From that, they are engaged to the sector with having a lot of trainings and workshops. Then I want to highlight some points from the private sector, because the private sector is actively involved in technology transformation in agriculture. Several mobile apps and platforms have been developed for specific tasks and supporting in the supply value chains. These are some mobile applications, Govimituru, Govinana. This is actually a special one. Govinana is our teamwork. I will explain later. And Govinana like that. These are applications, and also almost all supermarkets are having their online marketplace for agriculture products. And also Locate and Eleru is providing platforms to buy and sell. That is a farmer seller platforms. Farmers can register, then they can sell, and customer can buy. This is another project called Propis. This is another huge one. They are engage in automated climate control and fertigation systems. That is held by CIC company. This is another one for agromet data. This is very important because data is very important, especially this climate changes. This is called Weather Guru. This joint project by Dialog and some other private sector company. This is sensor-based system. They are predicting data. At least you can see future 10 days. There are more other private sector companies involved in agriculture innovation solutions in Sri Lanka. They are providing various kinds of solutions, including IoT applications, especially in automation, in protected houses, then software systems for agriculture, not only forestry, fisheries, livestock, and other related fields. There are some companies involved. If we talk about drone technology, this is emerging one in Sri Lanka. Use of agricultural drones. Now is several private sector and government institutions are working on this. Especially Department for Agriculture, then Rice Research Institute, Rubber Research Institute, Forestry, and all other universities are working on this. They are using especially for research purposes. And there are some private companies. They are selling drones, especially agricultural drones, and also they are they have services. We can request, then we can apply this technology for our sector. But there are some barriers because in Sri Lanka, you know, it's a very small country and we don't have large scale farmlands. And also we have some, if you talk about coconut cultivation, we have recently we have a big issue, that is white fly issue. But we can't use drones to overcome that because if you spray using drones, it's only applied to the canopy, but this disease and damages are in downside. That is a problem. Okay, let me talk about some innovative applications we have done with our university, Pune University, and also we have collaborations with other universities and private sector. Especially this is IoT-based agriculture system we have developed with the support of University of Moratu and Dialog company. We have here automated system, especially for protected agriculture, maybe polytunnels or protected houses. Normally, we use here the basic control like temperature, humidity, and maybe we can control light, duration, and also fertigation. Actually, this is very important because we have good findings here. This is the portal for the control. This is the interesting thing. The average yield increment was 40 to 42%. This IoT protected house when compared to the conventional protected houses. And this is very important. Right. This is another project we have here, because you know that in protected house agriculture in tropics like Sri Lanka, the big issue is temperature, especially in low country wet zone or dry zone here. This is a research on double roof system to reduce the temperature rise. You can see here the one roof, this is roof 1, then you have open space, then you have roof 2. This is covered by insect proof net. This is also very interesting. We have research, you can reduce 2 to 3 degrees other than basic design inside the house. And also this is another project we use that earth to air heat exchanger to reduce the heat inside the house. And this is another one, we use this same IoT system for mushroom cultivation. And these are new research currently going on. We are doing research with undergraduate students and also postgraduate students. Shape modification of standard grow bags, open top grow bags, to evaluate the effects of root growth, yield, and level of fertilizer. Another one, a new fertilizer application for protected house, especially cultivation, instead of currently available liquid fertilizer. This is actually, we are doing with the Crystal Agro company. And also we are, some others are in the pipeline, development of new liquid fertilizer formulas, and also development of software system to analyze nutrient deficiencies in protected house cultivation. Especially this is actually an ongoing project. Yeah, this is the last one, Govinana. This project by a team, the company Vidya and our university, the head project with the government project, and Western Sydney University, and also UCSC, that is from Columbia University. It's a teamwork, it's an application. I just go through a few slides about the application. You can see there are several modules: crops, weather, feedback, community, then activity calendar, growing information, harvest, exchange. This is actually very important because if you log into the system, you can give some information about you. So then system will show you the crops available only to your area. That's very important point. And also up to now we have included various types of crops like vegetable, root crops, fruit crops. And you can see some crops already we have 39. Now we are still developing, still adding some more crops. And this is just about the modules. I don't go with all. And this is how it's exchange. This is a new one. You can, if you have the access, you can exchange with your peers. This is a system you can register with other peers, then you can request or you can share. That is another important feature of this application. This more shows about that harvest exchange. This is about helpful information. This is actually another good one. That this module, you have all other information. This is the know-how, because you know, this knowledge is very important about data, right? So we have included common guidelines, making of organic fertilizers, how to use them properly, pest control, and urban home gardening, and many more we can include to this module. I think I will invite you all to download this app and have experience if you wish to have a proper home garden in your house or working place. But this is active only in Sri Lanka. If other countries are interested, please join us to expand this to your country also. This is open, we can go with more. It is active in 3 languages currently: English, Tamil, and Sinhala. And if needed, we can include more languages. Right, I think that is what I wanted to explain you about the country. Actually, I'm sorry to that I don't have other research data, but other institutes have done, because we have several universities, state universities and private sector universities, and also several agriculture faculties and technology faculties.
Okay. Yeah. So thank you, Professor Piyaratne. It's very interesting to see the developments in Sri Lanka and quite good utility of ICTs in agriculture systems. Without much ado, I think I will call up immediately if any burning questions are there. Because of the paucity of time, we can probably take one or two questions. So anybody has any questions, please, both online and offline? Virachai-san, in case if anybody is there from that room, please ask them to raise.
Hello, Adi-san. No one has question now.
Okay. So, Professor Piratne, from my side, if you allow me, I'll just ask about a couple of questions.
Yeah.
I'm seeing quite a good developments. Do you have any benchmarking of this data so that people can utilize this one and then make more innovations and collaborate and equity and things like that? Do you have anything? I mean, what I'm saying is these days open science data is really picking up a lot, and we have one chair in this very room, Professor Virachai. He is the one who is leading this open data working group. Do you have anything from this side, any open data or benchmarking data?
Yeah, I
from
think
your
Adi, this is one problem.
Ah,
Because we have data, yeah, especially Department of Agriculture, they have data, and universities, they have data, and some other institutions, they have data, and especially HOTI, that is Hector Cobaga Agrarian Research and Institute, they have a lot of data about marketing and all products data. But we have to have a common platform to store this data. That is one issue, and this is a challenge.
Okay, fine. And how good is your Agromet network? Because you said that now Weather Guru or something is there, and whether Climate Smart Agriculture Project. Do you have good network of these Agromet data in terms of weather stations or leveraging the sensor data with common platform?
Yeah, that is we have the Department of Meteorology. They are collecting data. They have a very sound database there. We can use this data. Even in our university, we have climate station. So automatically data are recorded and sent to the Department of Meteorology. Okay.
And I'm sure you must be taking care of the capacity building, because it goes down to the user agencies, both IT as well as domain specialists must be coming together.
Yeah.
Okay. Right. So if no questions are there, then friends, I will move on to the next slide, and I would like to thank Professor Piratne for this. Let's give him a big hand from the APAN Agriculture Working Group session.
Okay, thank you, Adi. Finally,
Thank you.
Finally, I want to thank for the entire organizing committee of the APAN 56 for facilitating me, and special thanks to go to Professor Subhash Jayasinghe, Dean, Faculty of Technology, University of Pune, who nominated me to this speech. Thank you very much. Have a good day.
Great. Yeah. So if you are around, please be around, Professor Piratne, so that we can have more discussions, or if any such questions are there and all. Yeah. Thank you very much. May I now call upon the second speaker from MAF, Japan, Mr. Mitsuru Kameya-san. Is Mr. Kameya-san, are you around, please?
Yes, I'm here in the lobby. So.
Great. So you please go ahead. Now the stage is yours now. The topic is your departmental activities to promote digital transformation of agriculture in Japan. Please go ahead.
Just a moment.
Yeah.
Could you help me?
I think I already opened. This is not the first.
Yes.
Okay.
Okay, I'll start my presentation. Good morning. My name is Mitsuru Kamiya from the Agriculture Forestry and Fisheries Research Center of the Ministry of Agriculture, Forestry and Fisheries of Japan. I will
Kamiya-san,
yes.
can you share the screen? We are not able to, at least I'm not able to see. Yeah.
Yeah. And I'd like to make a presentation of the activities of the ministry. And
Yeah, it's coming now.
to promote the digital transformation in the agriculture sector. And this is an example of the application of ICT technologies. The concept of the use of ICT covers a wide range of areas. It includes so-called smart agriculture, which refers to agriculture using advanced technologies. On the other hand, the streamlining of an administrative process is also an important area for implementation. I hear that Dr. Nemiya made a presentation of the green strategy of the ministry as well as smart agriculture in Japan in APAN 54 last year. Today, I would like to focus on the efforts of the ministry to streamline the administrative process in order to support food and agriculture sector in Japan. The substance of today's presentation is too much for 20 minutes, actually. So please read the slides available to be available on the website in detail later. And I will just talk about the outline. At first, I'd like to talk about the need for digital transformation in agriculture in Japan. Agriculture industry in Japan has various challenges, including the severe labor shortage due to the decline and aging of farmers, and the decrease in local government employees dedicated to agriculture sector. Japan is composed of 47 prefectures, and each prefecture government implements its own project customized for its local condition in line with the central government's policies. The local government employees of the prefecture and municipal level to operate their projects has been decreasing. To address issues such as aging and labor shortages, and to improve productivity, and to make agriculture growth industry, it is essential to realize digital transformation, DX. And another point I have to mention is that the data-driven response to the consumer needs has been more and more important for further development of agriculture sector. In this sense, the utilization of ICT for agriculture production and administrative procedures would contribute to solving these issues. The merit of digital transformation would be these three points. Farmers can focus on their own farm management, and local government officials can effectively focus on interacting directly with farmers. And the ministry can make policies based on data. In other words, it can implement EDPM. Now, I would like to talk about DX initiative in agriculture. DX initiative in agriculture was formulated based on the comprehension of current status and present issues, and is composed of the sections of idea and purpose, and future vision, and basic direction, and milestone, and projects and points to be cared for implementation. In response in response to the need of digital transformation in the agriculture sector, a series of sessions a series of sessions of expert committees was held from January to March 2021. In addition to the discussion in this committee, public view from the stakeholders of the food and agriculture sector was widely invited. The DX initiative in agriculture was published in March 2021, taking into account the discussions in this process. I have prepared 4 slides to explain this initiative. This slide shows the idea and purpose and future vision of food and agriculture and milestone in the realization. So in detail, please read later. I can say various kinds of research and demonstration have been implemented. And you can see significant progress in many areas. But we should move forward further for practical application of digital technology in food and agriculture sector. For example, as for the administrative procedure, online service of administrative procedure has already introduced and promoted, but much room for improvement exists. We still mostly rely on information that was submitted on paper from the clients. COVID-19 materialized the challenges of the food and agriculture sector in Japan. We listed them on this slide. There are 5 items. And for a basic direction of DX in agriculture, we would like to emphasize these 6 points. The first one is DX is digital transformation is promoted in line with the overall government's policies for digital transformation from the digital agency, such as digital 3 principles and 10 basic principles to build the digital society. And this is common strategy for Japanese government. And various players related to food and agriculture sector will be able to fully utilize digital technology. In other words, they automatically share necessary data to solve their own technical issues. And third one is digital transformation would create new collaboration among various players. The collaboration among various players would fuse the traditional knowledge and new technology and service to promote innovation. The fourth one is various players of the food and agriculture sector should take more consideration on the view of consumers based on the data on the needs of the consumers and users of the service. The fifth one is ensuring the smooth direction and smooth distribution of food and related service in response to the social changes and demands following COVID-19. And of course, it contributes to the achievement of SDGs. This slide is quite. This slide has quite a lot of characters. Sorry. There have been implemented 39 projects to achieve DX in agriculture. Roughly, and they are divided to 3 categories. The first category is the project that are closely related to on-site. The second category is streamlining administrative procedure in the ministry. And third one is the establishing the basic to connect on-site and administration. And some of them are related closely with each other. So today, I don't have time to explain this project, but if you count these lines, it makes 39. Okay. In implementing this project, it is important to make plain explanation on the new digital technology and service to consumers and users, so that they can use them and recognize the usefulness. And improvement of the service following the feedback from consumers and users is also indispensable. And it is also important to implement appropriately the measures for information security. The ministry is going to strengthen the organization for data management. This slide shows the expected future to be achieved through digital transformation in agriculture. We expect a new ecosystem of agriculture, in other words, farming as a system, FAAS, FAS. By fully utilizing the digital technology, various actors share data and make innovation to overcome various outstanding issues, as well as to create and provide values in response to consumer needs. And a platform is to be established and fully utilized for data coordination. Now I would like to introduce some projects for digital transformation in agriculture. I will explain eMAP project. This is a common online application system of map. And eMAP map project. This is a common geographic information system. Because they are closely related to the review and the streamlining of the administrative procedure for agriculture sector. And if time permits, I will briefly introduce the promotion of smart agriculture. First, I would like to explain about the eMAP project. The eMAP is an application service to achieve digital first and only one service. The stakeholders of the administrative procedures, including MAP and local governments and related organizations and farmers and so on. The related organization conduct on-site level operation. For example, the management of farmland information and agricultural insurance and so on. And it is essential to manage uniformly the farmland information for streamlining the administrative procedures. The eMAP project established the online application system for administrative procedures based on laws and ordinances under the jurisdiction of the ministry. This system covers procedures concerning both national government and local governments. And this system also intends to build a database that enables policymaking based on evidence and data. And this system also prepares support functions for the elder farmers who are inexperienced in online applications. The ministry has started the development of a common geographic information system, GIS of MAP, And this is called an EMAP project to integrate on-site farmland information. I will explain on the next slide. Now I talk about the current status of the management of farmland information. You see unhappy farmers on this slide. It is not only farmers, but also the officers of related organizations who are suffering from the overwork. At the on-site level, agricultural committee are in charge of operation of agricultural land rights. And regional agricultural councils are in charge of the applications of stabilization measures of income. And NOSAI is in charge of agriculture insurance to cope with national disasters. Traditionally, the farmland information has been collected and maintained separately by these organizations, and the items of the information are not the same. Therefore, farmers must submit the application separately to each organization, and the information submitted from farmers is often handwritten. So the officers of the organizations have typed the handwritten information separately. On-site inspection of the farmland are also conducted separately. These activities are time-consuming, and sometimes the information is inconsistent with each other. This is the reason that the ministry has started the development of a common geographic information system, GIS, to integrate on-site farmland information. So EMAP project is to establish an integrated farmland information system. By system linkages with online application system, EMAP project, we expect the workload reductions at first after full implementation of the EMAP project. So, yeah, you can see typing and number of the paper sheet will be 0. Yeah, and improving efficiency, but using tablets for on-site inspection. It is estimated that reduction of operations by 60%. But this project has been implemented, and it still has a lot of issues for implementation at on-site level. For example, the purpose and usage of the database of each organizations are different with each other, and inconsistency of the data exists. It is not an easy task to integrate into a uniform database. Moreover, the farmland in Japan is often scattered and irregular shaped. The fluctuation of description or spelling of Japanese language is also a challenge to overcome. But this project will contribute to the workload reduction, both for farmers and officers. The ministry will proceed this project to make all the stakeholders happy. In summary, EMAP project aims to make a common and consistent database system for farmland. Each registration data will be maintained by the respective governing bodies through various opportunities. The data will be kept up to date and accurate by the cooperation of each stakeholders. On the other hand, it goes without saying that close attention to the security and personal information protection laws should be paid in utilizing data. Steady training activities are needed for officers of central and local government, as well as farmers, for the successful operation of this system. Related to the introduction of online process, Ministry has also been implementing the full review of conventional administrative procedures. It can be regarded as business process re-engineering in this ministry. This project is including understanding the present situation and developing workflow diagram. It is visualization of the workflow and reduction of the documents and reporting items for applications. MAF staff members are also participating from the user's point of view to develop the screen layout. And careful explanation and training activities for MAF staff, including central government staff, are necessary for the operation. Now, I'll talk briefly about the smart agriculture. Well, smart agriculture is also an important part of the digital transformation in agriculture. Smart agriculture refers to agriculture using advanced technologies such as robots, AI, and IoT. It contributes to the reduction of workforce, simplified information sharing, and efficient agriculture management. The Smart Agriculture Demonstration Project has been implemented since 2019 and has been demonstrated in 217 districts nationwide so far. This project aims to introduce advanced technologies to production sites and to clarify its management effects. This project analyzes the effects of smart agriculture and horizontally expands demonstrative activities to the field. And at the same time, deal with the challenges comprehensively and promote the acceleration of implementation on site. Of course, there are a lot of challenges on implementation. For example, high initial costs or shortage of human resources like that. And based on the results of the demonstration, we are going to further develop and disseminate new agriculture support services to reduce cost for introduction and enable everyone to utilize smart technologies. Human resource development and data utilization through on-the-spot guidance are also important issues. For further promotion of smart agriculture promotion comprehensive package was revised in June 2022. This package is composed of 6 sections, and this slide and the next slide are the substance of the package. By 2025, almost all farmers are to utilize data to practice agriculture and improve their management abilities. We are going to strategically promote overseas expansion of smart agricultural technologies. Asian countries are in the main area for collaboration because rice cultivation is common in this area, and similar type of technologies may be applied. And we are promoting the overseas expansion of smart agriculture through sending experts and active participation in international discussions. Okay, thank you very much for your attention. Thank you very much.
Thank you, Kamiya-san. I'm good to see this DX developments in your country. Can I, I'll just maybe again, maybe one or two questions maximum from the audience, in case if anything is there.
Oh, there's one. Yeah. Yes, please.
Thank you for your presentation. My name is Basuki. I'm from Indonesia. I think it's very nice to see your presentation. May I ask you a question? What is the big obstruction or obstacle about the digitalization of the in the farmer or in the agricultural sector? Thank you.
Thank you very much for the question, and very good question. Well, I'm now working for the central government, and of course, what farmers are thinking, or the local level organization are thinking, is different from the central government. I think this is a very important issue because, central government has dream to promote digital transformation, but it is not easy for local level. For example, for very aged farmers to understand the necessity and merit. If, for example, if farmers understand the usefulness of the digital transformation, they will actively introduce by themselves, even if they need cost. But if they don't understand, of course, this is not only for digital transformation, they won't introduce new technology. So I think this is the most important issue that change the way of thinking of the local people. So to do so, I think one of the important, one of the useful method would be to show the usefulness of the digital transformation. For example, in the farmers level, there are a lot of kinds of farmers. There are a lot of aged farmers, and others are quite young and active and willing to introduce new technologies. So my opinion is that if, for example, to have the demonstration farm, for example, is to show the local farmers would be a good method. This is this is not the perfect answer, but it will be one of the solution. It will help to solve the problems. Is it okay?
Yeah, thank you. Because I think this is the same situation in many countries, even in my country. Because sometimes now there is no young farmer because it's difficult to work in the agriculture sector. But the other things like, okay, we have to have another, not decision, alternative to young people to attract to become a farmer using the technology or something. So that's why I asked for the obstacle, this obstacle of the maybe.
Of course, budget is of course.
Thank you, Kamiya-san. Basuki-ji, I agree with you. We need to somehow bring this reverse migration. That is the most important thing as a challenging job for many of the countries. In addition, we have language barrier, literacy barriers, and all those things, big challenges in the rural sector, and I'm sure we're going to overcome with that. So thank you. If no questions are there, Kamiya-san, thank you very much. I'm sure the participants would be interested also to see whether they can collaborate under your overseas participation. Thank you very much, Kamiya-san. Thank you.
Thank you very much.
Thank you. My pleasure. The third speaker is Mukesh Kumar Vishal from my organization in the Institute of Technology, Bombay. So meanwhile, Mukesh, please go ahead and then share your screen. Friends, in India too, a lot of digital transformation is taking place, and digital agriculture is also the buzzword now. As a part of it, we have some dedicated systems, one of which is Nanaji Deshmukh Phenomics Center, which is situated in New Delhi. It's a national facility. People can collaborate and then take the data and use that for more innovations and things like that. Mukesh, please go ahead. Please go ahead. Yeah. The one what he's talking about is going to be useful for both agronomists and plant breeders. Mukesh, please go ahead. Not yet. Have you shared the screen? Mukesh? Mukesh, you can probably be on audio only. Remove that video. Please share the screen. Or can you send by email to the organizers immediately so that they can also share it?
Hope its screen is.
Yes, please. Please go ahead. Please go ahead. Yes, you are audible and visible. Please go ahead and try to finish it on time. Yeah.
Okay. Good morning, everyone. I'm Mukesh Kumar Vishal, going to present my work. So, welcome, namaste, sadren pili ganim, yokoso to all our audience. My topic is leveraging the plant architecture analysis in rice or Rhiza sativa with image-derived morphological traits in phenomics. This work is done at IIT Bombay in collaboration with Nanaji Deshmukh Plant Phenomics Center under supervision of Professor Adi Narayana. So the major goal of Plant Genome Project is tapping diversity for food security, nutritional security, health security, and ultimately to improve the quality of life in Southeast Asia or developing nation like India. So this is just for showing the diversity in genotype. Like on planet, we have abundant diversity in genotype. From that, we want to achieve our goal-oriented genotypes for selection. So just to give the origin and definition of problem, we know that there are literatures and research which ascertain that there is going to climate change, unavoidable climate change, and in that the temperature will increase by 2 to 4 degree centigrade, and also there is chance to there is abiotic stress scenario, and across globe, especially in Southeast Asia and in India, frequent drought are observed. So there is need to have climate resilient genotype, because to feed populous country like India, and also like most of the populous country which falls in Southeast Asia, and rice being one of a staple food, we have to go for water efficient genotype or drought resistant or genotype. So considering that at our center, we took this work. So obviously we need climate resilient genotype, and to have climate resilient genotype, we need efficient way of measuring the phenotype. And for that, obviously one of the solution is emerging high throughput plant phenotyping, where we wish to measure plant traits or phenotypes in efficient way as compared to traditional way of phenotyping. So HTPP borrows and involves the principle of remote sensing, image processing, computer vision, including artificial intelligence, and it involves array of sensors, RGB to hyperspectral or multispectral sensor, to capture the different traits of related to physiological, morphological, and other interest of trait. It has advantage obviously because at a time throughout 24/7 and for entire cropping period, we can monitor our experiment, or we can take the images, or we can record the data. That is quite tedious or not possible in traditional phenotyping. So thus, to give what is high throughput plant phenotyping and what is phenotyping. So phenotyping is application of methodology and protocol to measure a specific traits related to plant structure of function, with trait ranging from cellular to whole plant level. In our present experiment, we will go to talk about morphological and color traits. And what is high throughput phenotyping? It's an automated or semi-automated, non-invasive, multifunctional and comprehensive assessment of plant phenotype in response to their genetic and environmental characteristic. In gist or in short, its genotype means seed of a plant. When it's interact or grown in particular environment, then whatever the expression is observed for that plant is phenotype. Like in our case here, we are taking rice and we have grown it in certain environment at Nanaji Deshmukh Plant Phenomics Center. That is environment, this is environment, this is genotype, and entire this plant is phenotype, is expression of genotype and environment. So obviously we are talking about abiotic stress phenotyping, because abiotic stress is quite oftenly observed stress in our country as well as globally. So we are talking about drought. Out of many abiotic stress ranging like drought, flooding, extreme temperature, salinity, soil nutrient deficiency. So in drought, as I will give one analogy, that as a human body or one is exposed to extreme heat while running, so he will like human will radiate, it will transpire a lot, there will be more physiological changes, and there will be like some metabolic changes. Similarly, when plant goes under drought stress, then it transpire more, and also you will there are morphological and physiological changes, like root will increase and stomatal closures will be there, So there are many physiological, morphological changes will be there. But in our present case, I am going to talk about morphological and color change. So this is a systematic flow diagram and objective of my work, where we are acquiring rice plant and we are taking side view 0-degree angle and 90-degree angle. Then we are pre-processing it, we are resizing it, we are doing segmentation and binarization of images to further annotating the two important traits like column angle and column width. And then we are also calculating that one with ground truth data, and then with image processing and computer vision, we are counting, we are estimating those traits in silico, like in silico, and then we are finding correlation, and then finally we are clustering the genotype. So overall goal is to increase the genetic gain, efficient phenotyping, and selection of better genotype. So this is bird view of IWOD view of like our phenomics lab, Nanaji Deshmukh Plant Phenomics Center. We has 4 greenhouse chambers where we can accommodate 1200 maximum plant at a time, and this is imagining chamber. So like in present case, and that entire plant will be mounted on inside imagining chamber on car, and then each plant will move to imagining chamber where around 7 sensors are there, but I am presenting here for RGB sensor. That entire plant will get imaged, and then all imaged data will be acquired at our local server, and then whatever the image is acquired, it has top view and side view both, and with those acquired images we process and analyze it for our own selection purpose and inferential work. So this is just to give field view, lab view of the experiment, rice experiment. Here I have taken subset of 3 data: IRI GWAS genome-wide association data of 2018, IRI nitrogen use efficiency NUE 2019 dataset, and IRI water use efficiency 2020 dataset, just to have uniform dataset for abiotic stress. And that each we are taking RGB image. For RGB image we have 2 view, top view and side view. Each view is of 6526 by 4384 pixel, and vice versa. For side view it's 438 by 6576 pixel, and entire this image is captured by ProSilica GT6600 sensor. So just to give that detail of image, this is top view of particular one genotype Anjali, and another is black gora. This is susceptible genotype, and this is resistant drought resistance genotype. So this entire facility was developed in collaboration with LamnaTech, and this company is from Germany. And in present work we are taking our RGB image. I already told, like image size which is captured by this sensor, and the entire experiment, this entire experiment is of plant to sensor type. This phenomics facility is of plant to sensor type. So in that, plant moves to sensor, like initially I showed in photo. So here entire experiment is of port experiment, where we took 4 replication of each genotype in 2 conditions. One is drought condition, where we give moisture deficit stress up to 12.5% of soil moisture content during maximum tillering stage, that is 35 to 55 days after transplanting, while the other set was grown in well water condition at 25% SMC, and this is controlled condition. So this is like mounting, side mounting and top mounting of our sensor. So we have hypotheses like we want to classify plant based on 4 category, that is erect, semi-erect, open type and spreading type. That is common convention in rice. So for that, we estimated culm width or total girth of the plant. And we also counted number of tillers. For that, we resized the entire image, to 400 by 600 pixel size image. Then we did binarization, then we did conjugate, then we did dilation, and simultaneously we removed the outlier with ultimate Z score, and then with simple extreme pixel difference we estimated the culm width, the difference between 2 extreme value of this area, culm area, that is we can say total culm area, and that gives also if there is drought, this growth will be if there is drought or if deficiency is there, and in that condition if genotype is susceptible, then if the genotype is susceptible, then we observed that there is less growth or less width in culm as compared to drought resistant plant or in well water condition plant. So this is generally a very common practice in traditional phenotyping. Only to conduct the experiment in phenomics and to screen the genotype in phenomics condition under high throughput plant phenotyping, we developed this algorithm. Simultaneously, we estimated the culm angle. So for culm angle, simple, we are putting coordinate geometry. We are taking 2 points as 40 pixel difference, and then the two tangents are drawn at extreme of this plant, and whatever the angle is there, that gives the culm angle, that is total culm angle, and entire for this that RMSC was up to 1 degree. So we found this is quite accuracy was quite good for this our model, and we calculated culm width, culm angle with other trait. I am just highlighting, like for large population within a click or less than 30 seconds, we can calculate the total culm width and culm angle with other traits, which is not possible in traditional phenotyping. So this is just one view of entire plant arising from our experiment. We observed notable variation in culm width of rice genotype. Like here you can see one well developed plant has wider culm width and number of tiller as compared to plant in drought. Similarly, like this is for one genotype, this is for another genotype. Similarly, this is associated with culm angle. If the plant is of erect type, then obviously the culm angle is less, but the entire plant architecture and number of tiller setting is depending on this culm angle or total angle. So with this angle also, we are able to measure that plant variation, and as well as we can group the entire plant based on this culm width, culm angle and other trait. So we found this major trait as compared to like people take biomass estimation also. We have done biomass estimation also, but we are just showing it like with vertical trait and these two trait also, one can classify the plant. So here you can see number of tiller setting and their variation of culm angle and culm width. So after that, entire genotype were clustered, and we found that most of the drought resistant genotype like Hira, which is established genotype, Nagina, all are falling in one group. So we can ascertain that this methodology is a proper one. It is ascertaining the result. Then we went for biplot of the traits. Apart from, like I told, culm angle, culm width, we took fresh bio mass weight, number of tillers, that dark green pixels near culm area, then total dark green pixels of plant. Then we also take yellow plant pixels, light green plant pixels, because if plant is under stress and it's susceptible, then obviously yellowing and light green pixel will be more at peak drought. So we found that our result was clear cut showing this biplot also, that culm angle and culm width is quite associated with biomass as well as number of tillers and the total green pixels.
Please go ahead.
So if the light green pixel is increasing or plant is in under stress, then light green pixels are more. Then we just wanted to estimate the projected shoot area and their relation with culm width. So we just in this result, I want to show you like projected area having positive correlation with culm width and also dark green pixels for entire plant. If culm width is wider or more, and then we observed that plant either is susceptible or in good plant is resistant or it in good condition, and number of dark green pixels were more, and PSA projected shoot area was also more, and ultimately the biomass. After that, for estimating this projected shoot area, we benchmark 7 machine learning models where we found random forest and AgWG perform very nicely, and error was root mean square was quite good. So at last, I would like to conclude that vertical traits, especially for side view image.
Okay,
of,
Mukesh, please
Yes.
speed up. Yeah.
For rice, like these all traits are in line with traditional phenotyping and they are efficient. Culm width is directly associated with biomass, number of tiller setting, and plant health status. And in our benchmark model, we found random forest and AgWG better one, and it was at 0.01 p-value. So we can ascertain that this method is quite good and that can be adaptable. At last, I would like to acknowledge Nanaji Deshmukh Plant Phenomics Center, which is under Indian Council of Agriculture Research and located at Indian Agriculture Research Institute, New Delhi. And this entire facility was set up under the ICR grant. Thank you very much.
Okay, thank you. Thank you, Mukesh. If any questions are there, please ask, 1 or 2 maximum, we can have it. Anyhow, we are all going to be there in the afternoon for further discussions. If any questions from the audience, please. Oh, Mukesh, do you have any plan to keep this data open?
Yes, sir.
Do you have plans to keep this data open? Because getting the phenomics data all over the world, not only in our country, although we do have this national facility, but getting the data is going to be very, very difficult. Do you want to keep the data as well as algorithms open so that people can use?
Yeah, yes, sir. It is in publication phase. So after
Hmm.
publication, we are going to put entire code in GitHub, and we will keep
GitHub.
it open, accessible to everyone, sir.
Okay, fine. And another question is, we were discussing yesterday, if you remember, bringing out these systems in field phenomics is going to be very, very difficult. I know you have told some rovers are there and maybe some indices can be used to automate and all. So, but do you have any such plans in future?
Sir, in market already professional like rovers are coming, which are taking care of field phenotyping. So
Okay,
in field with help of robotics or rovers, they will take all traits.
Okay, fine. Yeah, thank you. Any questions from online or from the very room in Galley Hotel?
Yes.
Yes, Virachai Sai.
Yeah. Not
Yeah,
not
please
me.
go ahead.
Basuki.
Ah.
Basuki.
Somebody else says Basuki. Yeah, please,
Of
Basuki.
course, it has to be Basuki.
Okay, so thank you. This is very nice. Presentation and working for the in the fatty field area. I will ask about the what is the relation RGB? RGB, you mean the red, green, blue, the data, and where is and then you mentioned about the machine learning with some specific like a random forest, SG boost, and others. How you run about this, and then when you mentioned about the RMSE or R2 square, can you give us some description about what the related from the RGB and then the data is running on the machine learning using the random forest and XG boost, and then have the R2 square and MSE and RMSE, and then can you describe about this? Thank you.
So thank you very much, sir. So like with our sir, we conducted this experiment, entire experiment for 150 rice genotype, and from 150 rice genotype we took 4 replication, and that entire replication was for 2 conditions. One was controlled and another was for drought. So at peak period, peak drought, that is after 35 days, and it was almost like 20 days of 25% of SMC. What we did, like we took that data, and then from entire plant, whatever the data we took RGB image, from that we estimated culm width, number of tiller, biomass, projected shoot area, and after PC plot, we've just correlated it to ascertain the result, and that we found that number of tillers, culm angle, and culm width is associated with biomass. So biomass indirectly is associated with projected shoot area. So projected shoot area was our predicted value, means we predicted our total number of total number of pixels associated with shoot area, means total shoot area. For that we benchmark 7 machine learning models, and in that random forest perform very nicely. So there we found coefficient of determination was 0.8%. That is quite acceptable for field experiments. And RMSC was it's around 1.83 into 10 to the power 4 pixels. So that value, if translate into area in centimeter, it's quite a small area value. So this is certain our result. So we took like 7 machine learning model. In that random forest and XGBoost perform better because these two models take care of non-linearity. And there was other model also like linear regression was there, ANN was there, but overall we found these two models were better as compared to others models.
Okay, okay, thank you. Okay, very nice work. Thank you.
Any further
Any-
question from the floor? Yes, please. One more, please.
Thank you,
Yeah.
Mukesh, for the nice presentation. I would just take comment or a question. Do you think that if you incorporate multispectral images with RGB, so it would be more beneficial to your results?
Yeah, actually, in our group or our phenomics center, we have other like sensor also, like we have like thermal images are there. So if we are integrating all sensors data, then obviously that accuracy and efficiency will increase, and also the result will result accuracy will be like higher, sir. Because for moisture estimation, moisture content, like apart from RGB, other sensors will be obviously they will a certain result with higher accuracy.
So do you
Have
think
you
in
used those-
continuation? Yeah, please go ahead. Please go ahead.
I'm just curious, have you used those sensors in your work?
Yeah, actually I am presenting here with RGB only. In general, like Nanaji Deshmukh Plant Phenomics Center has like 7 sensor. In that we have thermal sensor as well as NIR, hyperspectral NIR region sensors, and we have chlorophyll for chlorophyll measurement also there is one sensor.
Right, thank you.
Thank you. So do you think, Mukesh, why didn't you use multispectral for this? Do you mean to say for the sake of this biomass, you can make use of RGB, which you can want to promote it, or you want to do something biochemical? Do you want to promote the hyperspectral or multispectral?
Yeah, because I told sir, there are majorly three traits like physiological, morphological traits are there, and agronomical traits in general. So if we want to go for like biochemical level and understanding of physiological level also, then hyperspectral and other apart from RGB, other sensor will be like will be beneficial or will be quite good for other work. But RGB sensors are very basic and affordable. So I wanted to depict with RGB also, if we are measuring morphological traits or some important vertical traits, then we are able to analyze, at least we have a basic understanding of plant, and we can quantify that drought stress, and then we can group genotype also.
Got it. Yeah. Thank you. So if not, I am wrong. Is it Mr. Owais Muhammad was asking this question? Okay, Virachai San, if any questions are there from the audience or even from online audience?
Any further? Okay, if not, I think we are a little bit late.
Yes,
one
you're
thing though,
already,
is like many people here.
Yeah.
So I would like to take group photo. So if you
Yes.
don't mind, and then the people,
Yes,
all
yeah.
you please turn on the camera.
Camera.
So,
Yeah.
So yeah, so we can see that the many people here, you know, wow.
Great. Yeah.
Last time is the room smaller than this and packed, and now it's bigger and still packed. Wow, that's a good sign. Please, would you, before we have lunch, because the like 10 minutes shorter than the time, or we have to be back at 1:30 here.
Yeah.
So please quickly have a quick group photo. Thank you. Please, that's it. Just them too.
Thank you. Thank you very much, everyone, and we'll look forward for the second session in the afternoon. So you're still taking the photograph?
We have a photo session. Would you
Oh yeah,
still?
go ahead.
Yeah,
Go ahead. Yeah.
please. Yeah, everybody, if you could, just like
Can I request all online participants to keep the camera on, please? Similar
yeah,
time?
just bring the whole up, not just Adi. Bring all the people on the big screen, please. Yeah.